All right, 3.1 we won't be going over in class. It should all be review, but just for your benefit, I'm posting this video so that you can have a notes packet to refer to. So 3.1 is graphing equations. We're looking at a coordinate or Cartesian coordinate system, which is in a rectangular coordinate system. So plotting ordered pairs in a rectangular coordinate system is our first objective. This image here is a rectangular coordinate or Cartesian coordinate system, which is also called a plane, and it consists of two number lines that intersect at right angles at their zero coordinates. So referring to this picture again, we have our horizontal number line and our vertical number line, and where both number lines are zero is this point here where they intersect. We call the horizontal number line the x-axis. We call the vertical number line the y-axis. And the point where they intersect is called the origin. The four regions that are created by these two number lines are called quadrants. And the way that we refer to the quadrants is by number. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and those are Roman numerals. So 1, 2, 3, and 4. And we refer to each location within this coordinate system by an ordered pair, which has an x value and a y value, and we call it the ordered pair x comma y. The x value is referred to as the x coordinate, and the y value is referred to as the y coordinate. And the x coordinate is referring to along the horizontal number line, where along that number line we are going, and then we go to the corresponding y value or the y coordinate as well. So our example 1 is using these values to find a location on our plane. So part A, you're looking at 2, -1. So along the horizontal number line, we're going to 2, our x value of 2. And then we go along the y axis here to -1. So if we go 2 to the right and 1 down, then we are left at this point, A, which is in quadrant 1, 2, 3, 4. So quadrant 4. And then point B, we go 0 horizontally and 5 vertically. So we go up 1, 2, 3, 4, 5. Here is point B. And that is on our y axis. I apologize for the handwriting. I am typing on a trackpad. All right, part C, we're going -1.5 in the horizontal direction and 2.5 in the vertical direction, which lands us here. Point C, which is in quadrant 2. And point D, -2 in the horizontal direction and 0 in the vertical. And that lands us on the x axis. All right, so going on to objective 2, we want to determine whether an ordered pair is a solution. So reminder, this here, the coordinates x comma y, is an ordered pair. And we want to know if that satisfies or is a solution to an equation. So determine whether 0, -12 and 1, 9 are solutions to the equation. And the way we do this is by substituting those values and seeing if we end up with a true statement. So our equation here, 3x minus y equals 12, and the point that we're testing is 0, -12. So I substitute 0 for x, 3 times 0, minus, and then our y value is -12, and we want to know if that equals 12. So following order of operations, 3 times 0 is 0, minus and negative is addition, and so we end up with 12 equals 12. This is true. So yes, it is a solution. Okay. For the second The second ordered pair, we're going to do the same thing. 3x minus y equals 12. 3 times 1 minus 9 equals 12. Order of operations, 3 minus 9 is 12. Negative 6 is 12. This is false, so it is not a solution. All right, so the way we test if a point is a solution is by substituting in those values. And what this means is that the point 0, negative 12 does lie on the graph of this line, and the point 1, 9 does not lie on the graph of this line. It's off of the line. Okay, so now we want to know how to graph linear equations. The way we find more points is by creating a table. So again, we can create x, y into a table, and we want to substitute values. So let's say I substitute the value 1 for x. I have 3 times 1 minus y is 12. So let's do 3 times 1 minus y equals 12. Move this down a little bit. 3 minus y is 12. Subtracting 3 from both sides, negative y is 9. So that means y is negative 9. So when x is 1, y is negative 9. When x is 2, I have 3 times 2 minus y is 12. So 6 minus y is 12. So y is negative 6. And when x is 3, you'll find that y is negative 3. And then I want to plot these points. So negative 9 is off of my graph, so I'm not going to go ahead and plot that, but 2, negative 6 is right here, and 3, negative 3 is right here. And using those 2 points, I can graph approximately that line. Okay? And remember, a line goes off to infinity in both directions. It doesn't stop moving in either direction. Otherwise, it would be a line segment or a ray. So a line goes off to infinity in both directions. And a linear equation in 2 variables can be written in the form ax plus by equals c, and this is what we call general form. And when we have a general form such as this, it forms a line. So a linear equation forms a line. Looking at example 3 now, use the graph of 300 plus 1/5 x to answer the following questions, and they give us the graph here. This little squiggle down here is called an axis break. Essentially what that means is that we have kind of cut out part of the axis to make it fit in a better screen. So if a salesperson sells $8,000 of products in a particular month, what is the salary for that month? We can see that from this graph. If we're looking at $8,000 of products and we want to know the salary, is going to be the corresponding coordinate. So it's 4,600, and this is in dollars. So dollars 4,600. Okay, and that was directly from our graph here. And then if a salesperson wants to make more than $5,000 per month, what must be sold? What must be the total amount of products sold? So we're looking at $5,000, and we're looking at how many products, and that is 10,000 products. So 10,000 products. All right. So now a little bit more vocabulary. The x-intercept is where a line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. To find the x-intercept, we're looking for where y equals 0. And to find the y-intercept, we're finding where x equals 0. So if we're thinking about if we're on the y-axis, then our x value, our horizontal value is 0. We have not shifted away from the origin. And similarly, if we're on the x-axis, then we have not shifted vertically at all, so we have a y value of 0. Okay? Looking at example 4, we want to graph y equals negative 2x plus 3. Again, using a table of values, we can say x, y, that was a very long y, all right? And using the intercepts, I'm going to look at when x is 0 and when y is 0. So what happens when x is 0? That whole term goes to 0, so y has a value of 3. And what happens when y is 0? Then we have 0 equals negative 2x, negative 2x plus 3. So adding 2 to both sides, we get 2x equals 3, or x equals 3 halves. So that means our x value here is 3 halves. So when I plot that, 0 horizontal up 3, and then positive 3 halves, which is 1.5, and down 0. So this is the line that you end up with. And again, it's a line, so it has arrows on either end. All right, moving on to objective 4, we want to graph nonlinear equations. And to do this, you're going to do the same thing. You'll have an x value, x. Let me do this. You have an x and a y, and you're going to substitute values. So for x, we'll say our values will be negative 2, negative 1, 0, 1, and 2. And when you substitute those into the equation, you'll find negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So go ahead and plot these points. We have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So this makes what we call a parabola. And a parabola also extends to infinity from both ends. All right, and then our last example here, y equals the absolute value of x, and we'll do another xy table. Okay, if our x values are negative 2, negative 1, 0, 1, and 2, absolute value of negative 2 is 2, absolute value of negative 1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, and absolute value of 2 is 2. Plotting these points, I have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. And this looks like that's going to keep going, and whoop, that's going to keep going. Now notice the difference between these two graphs. The absolute value graph looks like a V, and the parabola or the parabolic graph looks like a U. Okay, these are two important graphs that you should know the shape of. And that's it for 3.1. So go ahead and take a look at the Math Excel, and then if you have any questions, please come see me outside of class time.